Hello everyone, let us now discuss how can we solve this problem. Merge operations to for minimum travel time. So we are given with L kilometer road length and integer n and integer k and two integer arrays position and time, each of length n. An array position lists the positions in kilometer of signs in strictly increasing order with positions of 0 is equal to 0 and position of n minus 1 is equal to L. Each time I represents the time in minutes required to travel 1 kilometer between position I and position I plus 1. You must perform exactly k merge operations. You need to remember this again. We need to perform exactly k merge operations. In one merge operation, let us see what we need to do. You can choose any two adjacent signs at index 1 and index I plus 1 with I greater than 0 and I plus 1 less than n, and update the sign at index I plus 1 so that it becomes time of I plus time of I plus 1. Remove the sign at index I. Return the minimum total travel time in minutes to travel from 0 to L after exactly k merges. So what I am taking is just this one, right? So let me take this 0 to 9 14. So here I am 0 and 2 and 5 and then 9 and then 14. So these are the values, that means the signboards. So we are asked to go in 3 kilometer, like something like 3 speed. So imagine this. Imagine yourself that at 0 to 2 I have asked for going at the speed of 3. That's it. Imagine like that in a real time example. 1 speed from 2 to 5 and 4 speed from 5 to 9, 4 speed from 5 to 9, and then 2 speed from 9 to 14. But I have given with 6 here. So why we are given with 6 speed is because if you merge this, then I'll tell you what, if I merge this, then the speed at this point, it will be 6 plus 2. So if I merge at I, the speed or the time, I'm saying this, the time will be I, the time at I and I plus 1. So remember this, that's why we are merging them. Now, if I imagine I have merged this, then what will be something like here, it will be 8, but there is no use of changing it, but I am doing it for your sake. Now, 14 minus 5 is the distance. 14 minus 5 is the distance. And for 1 kilometer, I have the speed or time of 4. And to travel from here to here, I will take 14 minus 5. 9 into 4 is 36. I think it's clear for you. Now what I'll do is go in the reverse order. So here k is given as 2. Sorry, I have forgotten to mention k is equal to 2. But here I have gone through only one merge operations. So what I'll do is just take k is equal to 2, right? K is equal to 2. Then you will understand how I am going to this algorithm, right? First thing I make is start from 0, right? The previous position I have is 0. Why? You will know one step by step why I am using this previous position. And this is this is k. This should be k. Sorry, this is k. K is nothing but it is 2 and time of 0. I'll tell you why. Why I am using this previous position? Let me just assume that I have removed these two. Now, what will the previous position? It will be this one. Now, when I imagine I just wanted the distance, then I need to calculate from 0 to 9. That's why I will take this previous position. as something like that. So by taking this previous position, if I remove any number of operations, take any merge operations, then I can easily get the previous position or previous uh, signboard where I have. Now here comes the actual recursion, right? Recur previous position is equal to 0. That means I am calling with 0 and k is 2. And here it will be current time, right? Current time is time of 0. Time of 0 is nothing but 3. Okay. Previous position is 0. Now it will call recursion of 1 to time 1. Why? No merge. This is a simply merge and no merge, as many people say as take and no take, not take algorithm. It is simply merge and no merge algorithm. No merge. If there is no merge, no need to worry about anything. The k will be the same, but the previous position will be 1, right? I think it's clear for you. Why 1? Why? Because I am starting, I didn't do anything for this 0. I am starting at here, right? Now I'm starting at here. Here also the same, no merge, only this will be incremented. But if you see time of I, why? Because if ever I do any merge operations here, then I need to take from here to here, here to here, I need to take what is the time? That will be this one, current time. I'll tell you when I do any merge operation, but for now, let me consider this as current time. And here, even then, I go to time of 2. Again, if I do any merge operations here and get, just assume here that I do a merge operation, then the current, the time I need to multiply it by is the position where I am minus the position where it is, the previous position where it is 2. Then this difference position of, it will be next index. I'll tell you what will be the next index, minus position of next index minus position of previous position, right? That's what I stored, position of previous position into the current time. This will be the current time. I think for now it's clear for you. So let us go to the another one. I'll go to the end, then time 3, then time 4. But here it will call for 5 index. It is going out of bounds, which is n. The size of the array is n. Now I have k value greater than 0. At this moment of time, I will return infinity. That means int max. If not, I will return 0 for this 5. Now I have returned what I have written here, infinity. Why? Because k is still greater than 0. Why I am returning this infinity? Why? Because if k is not equal to 0, that means we did do the exactly k operations. We didn't do exactly k operations. That's what the meaning of returning infinity means. So if k is not equal to 0, we'll be returning infinity. Now at this point of time also I got an infinity. So let me return it back infinity again. Let me return it back infinity again. Let me return it back infinity again and again here. Now I have infinity. But is it enough? I'll do a merge operation and go directly to 2. Beautiful. But wait, is by chance only one merge operation I can take at index 0? Absolutely no. I can take even 2, right? If I take 2 merge operations, then I directly go here. I think, I'll go here at 2, right? At 3, right? Now, just let us go by this 2, right? Now, at this point of time, I'll be getting what I'll get is recursion where the previous position is. Where is the current index? Current index is at 2. So 2 comma, I have done only one merge operation. So k is equal to 1. So I'll simply write 1. Now time of 0 is here. But I add this first. I add this to something variable like time. Something variable like time. So no, let me use another variable like timestamp or something, or temporary time, something like that, temporary time. So for this temporary time, I will add first here time of 1, nothing but time of previous position plus 1. I'll write it, time of previous position plus 1. So if I add it, then I'll get what I'll get. I'll get 1. Then after that, I will add where I am here, right? The next index is 4, right? Next index is 4. 4 plus 1 is 5. Okay, right? For now it's clear. So I'll return 5 as the current time for next call. But before that, every time I prioritize going to the no merge operation. Go to the no merge operation. If I do that, then I'll go to recur of next index is 3, and then still k is equal to 1, and here I got 5, but here I am at index 3, which is 2. The time is 2, so that's the current time. Then go to the next no merge operation. Then I'll get recursion of, I'll call recursion of 4 comma 1. Still 1k is 1, and at this point I have 6. Now this will call again no merge operation, and it is out of bounds and k is still greater than 0. Then return infinity or return 0, but I got k is greater than 0, so I'll return infinity. This will be written here, this will be written here, this will be written here, right? So I got this infinity. But what if I skipped it? Just skipped it. Now, that means I merged this index 3. Index 3, right? I merged this index 3. Now what will be the recursion? The recursion will be here the index is 4, and then k is 0, and for now it will be I merged 3 and 4. Okay, merged, uh, let me do this, 2 3 4, right? So index I is merged, so index I plus the time at I plus time at I plus 1 will be 2 plus 6, which is 8. So I'll call for 8, but here the no merge operation will return. Let us see what it will return. K is greater than 0. Is it greater than 0? Absolutely no. Now I will return 0 here. So our algorithm starts here. The actual intuition starts here. When I get a 0 instead of infinity, I will do something. What I'll do? I will do something like position of next index minus position of previous position into current time. What is this current time? Like, let me say you, the current time comes from 5. 5 will be the current time, and I am calling here, then this will call here, this will call here, and when I get 0, then only this will be executed. What is executing, I'll tell you. At this, it is calculating something. What is it calculating? Calculating 4, index 4. Index 4 is next index. Previous index is 2, right? Previous index is 2. Position at 4. Position at 4 is 14. Position at 4 is 14. And position at previous index, previous position is 2. So at 2 it is 5. 14 minus 5 is 9 into the current time. What is the current time? Current time I got it 5. 14 minus 5 is 9 into 5. 5 nines are 45, I think so. 45, yes. 5 nines are 45. Right. What I mean exactly is from here to here I made a merge. Then just here I got a 8. But here I got a 5. Why? Because I made a merge again here. So 1 plus 4 will be 5 here. 1 plus 4 will be 5 here. So from here to here, 14 minus 5, which is 9, I will get a time of 9 for every hour. Now, at this 3, it's the same. It's the same 3. 0 to 5, it will be 3. I'll tell you how. Now I have 45. So, 45 will be returned. Here it will return 45. Okay. Now this got 45. Okay. This got something which is minimum. This tree, this subtree got something which is minimum. Now what will it do is take this formula again. The next index is 2. I'll tell you what is this next index, how we are going and coming to this next index. So position of, as I said, next index minus position of previous position into current time. I think it's clear for you. For 2 times I have said this. Position of next index, I'll tell you what is this position of next index. 2 minus 0 is 2. 2 minus 0, sorry, at position of next index, 5 minus 0 is 5. 5 minus 0 is 5 and current time is 3. 15 will be added to 45 and 60 will be written at this point of time. But here, if you see, 60 is minimum than this infinity. So I'll consider this 60. Beautiful. Now I am going to this 3 by skipping these two indices every time by iterating. I'll tell you how the algorithm goes. Like, first thing, the base case. The base case in the recursion tree or recursion code is nothing but here I'm starting with previous position, and then I'm starting with previous position, and 2 is k and then current time. 2 is k and current time. Okay, for now it's okay. Now the base case is if if index or something like it is previous position, right? Previous position is equal to n, then I need to check something. If k is equal to 0, just return k is greater than 0, then return int max. If not, we'll be returning 0. This is how the base case will be. Now after the base case, I'm doing something. I'm taking this as in somewhere I'm taking this 45 as somewhere I'm taking this 15. So for that I'll write int answer is equal to int max. For now, int max is our answer, and the result will be recursion of this is the algorithm for this is something like a recursive code for no merge. No merge int result is equal to recursion of previous position. Just increment previous position and k is the same. I didn't do any operation, so current time will be not this time of index, sorry, previous position, right? So till now it's clear for you. Now what I'll do is if result didn't bring me an int max, it brought something like a lesser value. As I said here, it brought a 45. It brought a 45. Then I need to do something, right? Then the answer will be minimum of answer, comma, same thing, result plus. So I'll place it here, something plus. So what is this something? This something is nothing but and next index. Nothing but here I have skipped only one index, right? Sorry, I didn't skipped or merged anything. So at this point of time, I need just 2. So for that I will be taking position of previous position plus 1 plus 1 minus position of previous position into current time. I think it's clear for you. So position of previous position plus 1 is nothing but the next index. Next index is here, which is 1 minus the position at 1 is 2 minus 0 is 2 into 3. Current time I have gone from here to here, the current time will be 3. That's how it works. But what if I am taking merges? If k is greater than 0, what I need to do at this moment of time? At this moment of time, I'll take two things in operations. Operations is equal to 0 and the result is int max again. Here you might say result is initialized double times, but I'll place a curve bracket, so it is something like a bracket oriented or block oriented variables. Now I have for loop int next index. Next index, as I am saying, repeating again and again, next index is equal to previous position plus 2. Why plus 2? Why? Because here I have 0, then I gone to 2, right? I went to 2, which is previous position plus 2, and then I go and then I go and then I go one by one by one. But I'll take something like a temp something like that. Oh, let me take temp time is equal to time of previous position, sorry, previous position plus 1. Now previous position plus 2 is the next index. Okay, the next index should be less than n. Okay, next index, next index plus plus. Okay, for now I'll increment operations plus plus, but before that I'll tell you what I need to do. Here I have operations plus plus, and here operations will always be lesser. I'll tell you I'll tell you how. Result will be equal to recursion of where I have this previous position, but here I'm calling for previous, not previous position. I will be calling for next index. I'll be calling for next index, and what will be the k? K will be k minus number of operations, right? Number of operations, and the current time is temp time, and just add the temp time plus is equal to time of next index. That's it. At this point of time, I think you will get the answer is equal to minimum of the same thing, answer comma result, sorry, yes, result plus result will be added with position of next index. Previously, if you remember, I have gone through previous position plus 1, but here I am going through next index minus position of previous position, right? Position into current time. Is it so? Yes, it's the same, right? Operations plus plus, and after that I will be calling for the next recursive call. Recursive call will be here. The recursive call will be, yes, I have called the recursive call, which is by result, and I have added this result to the current time, and it will be taking the minimum every time. So this is how you solve this problem, and at the last return the answer, right? Okay, I think it's clear for you, but this won't be working here. Why? Because it is something like taking maximum time, more time, and it will give you a time limit exceeded. So for that we'll be using a DP. So instead of wasting your time, I'll just go to the DP solution. Here I have taken 3D DP, but simply I can't get a table or something like a blogs and explain you what does this DP looks like in a screen or any 2D screen or a pen and paper, right? Just imagine when you want to solve this type of 3D DP problems, just use the memoization. Previous position and then K and then current time is just stored in a 3D DP, right? Is not is equal to -1, then return. That's it. Then dp of this one is equal to dp of previous position K current time is equal to answer. That's only 3 lines, at max 3 lines we have changed in the whole code, and that's it. And I have given the code link in the description, and if you like this video, do share it to your friends and do subscribe to my channel. Thank you.